Dude, that was a great presentation. It was really cool getting to deep dive into Kubeflow a little bit, and yeah, really excited to see more coming out of that project. Jimmy, I think you did a really good job of overviewing a lot of the components of what's going on in the MLOps space, and especially highlighting the fact that there's a lot of immaturity in MLOps. That's something that I'm going to be talking about as well in my AI observability presentation, because honestly, I think that there is a lot of learning that we can all do around what are the best ways to make sure that we're implementing our models well in production, that we're deploying them, and that we're ensuring that they're able to stay reliable. So with that little bit of lead in, let me start off by making a slight correction or admitting to a white lie that I told when I submitted this presentation to Jimmy. So I told him that this would be about AI observability and how to fix issues with a machine learning model. But actually, what we're going to dive into is beyond just the model. We're going to look into how to fix issues with a machine learning system as a whole, right? Because at the end of the day, in order to get business value out of a presentation, out of a machine learning model, in order to be able to really justify to the business why machine learning is useful, you need a lot more than just the model. You need an entire system built around the model. Now, using this like cool interactive Zoom feature, either in the chat or raising your hands, how many of you guys have seen this resource before, this diagram? So if you've seen it before, I probably don't need to remind you that it's from Hidden Technical Debt in Machine Learning Systems, which is a really prominent paper put out of Google Research in, I think around 2014 or 2017. And this paper basically launched the careers of every machine learning engineer, every MLOps engineer, everybody whose job was to take the things that the data scientists produce, these machine learning models with these ML code, and actually provide value from it. Start to really create something valuable for the business, start to be able to serve the predictions that are being made by the machine learning model. And as you can see, it requires a lot more than just the machine learning code, right? To Jimmy's point, you need to be able to instrument and to orchestrate all of the processes around machine learning in an effective way in order to make sure that this machine learning code, this tiny little box, is able to have all of the outsized value that it's able to have. So with that little overview of MLOps and of the importance of MLOps in order to ensure the reliability and robustness of machine learning models when they're in production, let me go over the agenda of what I'm going to be speaking about today. So the first thing that I'm going to touch on is the fact that you need to monitor your machine learning models. But I'm going to take us a step beyond monitoring and talk about the fact that monitoring by itself isn't enough, and that it's really just the tip of the iceberg. That in order to get true value out of monitoring, you also need to have observability. I'm going to talk about, what is observability, and then I'm going to talk about the secret to observability. And I say this with a little bit of a wry smile on my face because our friends over in the DevOps world have actually known what's required for observability for years now. And we in the MLOps world are really just looking over their shoulder and starting to figure out what is it that we can do in order to enable observability within machine learning. So finally, go after tackling all of these conceptual things and talking about the value of observability, I'm going to get a little bit more hands-on and give kind of a blueprint or a recipe for what you can do when your model or your machine learning system degrades. And I'm going to offer two different approaches. One of them I term human in the loop observability, and the other one is automated MLOps or auto MLOps. But before we talk about that fun, exciting auto MLOps stuff, let's just like cover the groundwork with the fact that people need to have monitoring. You need to have monitoring for your machine learning models. So the high level overview of this is that models and machine learning systems degrade over time, right? There can be data drift issues, concept drift, covariate shift. There's all of these changes that happen in the real world that cause models to become stale, right? That cause them to not be able to perform as well anymore because the world that they were modeled on, the world that they're trying to represent, doesn't actually represent the real world anymore. But actually, in addition to data drift issues, the thing that I see most of my customers, most of the clients that I work with, most people, most MLOps engineers run into are actually not data drift issues, but data quality issues. So data quality issues happen when there's some kind of bug or problem in the data engineering pipeline, upstream of the machine learning model that cause or introduce data bugs. So like null values, NAs, lots of missing values, type changes. There's lots of different like just data typos that can occur that cause machine learning models to either completely fail or to just silently degrade in performance. So without monitoring, you're only able to find out from your customers when your models have degraded. And what this means is that you're fundamentally being reactive and you're only able to solve problems after somebody's already encountered this problem. With monitoring, you can be proactive instead of reactive and start to solve these issues before your customers even notice that there's a problem. Now, this is really valuable because it impacts, your customer's user experience, be your customer, somebody who's interacting with your application, be it somebody else within your own business who needs your machine learning predictions for something valuable, whoever it might be. You want to be able to service your customer effectively. And what that means is you need to monitor your model. Now, I've given talks before about ML monitoring. And if you're interested in learning more about the utility of machine learning model monitoring, the value of it, feel free to just look up Danny Leybzon machine learning monitoring. And you'll see a couple different videos where I dive a lot deeper into both why you need to be able to monitor your models and how to monitor your models. But like I was talking about earlier, monitoring just isn't enough. It's really just the tip of the iceberg for observability. It's actually a subset of the observability problem. Because what monitoring does is it tells you when there's something wrong, right? It lets you know that your model has degraded, that there's been data drift, that there have been data quality issues, but it doesn't tell you what to do about those issues, right? It doesn't help you actually solve the problem. It doesn't help you debug your machine learning model or your machine learning system. What it does allow you to do is detect the problem, but in order to solve the problem, you actually need observability. So this is the common flow from classic DevOps CI/CD, right? This continuous integration and continuous delivery diagram is meant to represent the fact that there's a continuous process related to deploying regular applications, regular software applications to the real world. There's all of these different steps and phases. Now, we've constructed our own similar diagram for the model lifecycle, for what it takes for a machine learning model to be able to be continuously integrated and deployed. First you start off by building your model, and then you want to test your model, you deploy your model, and you evaluate your model. And in order to be able to successfully get a model into production and to be able to keep it in production and keep it performant, you need to be able to get observability throughout the entire process. And in order to be able to evaluate the performance of your model, you need observability. So I've been talking a lot about observability, but it might actually be useful to define this term and to dive a little bit deeper into what is observability. So the textbook definition of observability actually doesn't come from MLOps. It doesn't even come from DevOps or from classic software engineering. What it really comes from is control theory. And in control theory, observability is meant to represent insight into the state of a system by looking at its outputs. And looking at its outputs is really the key representation here, right? We need to be able to understand a system based on the thing that it's producing. So one thing that observability, of course, requires is historical state, right? We need to be able to track changes in the system, in our case, track changes in our model, which requires us to be able to look back over time at the performance, at the predictions being made, at all of these different components of our machine learning system. And all of that creates historical state that we can compare our present state to. So importantly, what observability does, what this insight into the state of the system does, is it allows you to do postmortems, and it's really the key to debugging, right? Because in order to be able to debug, in order to figure out what's wrong and solve whatever the problem is, we need to be able to understand the problem and understand the cause of the problem. And that's what observability is. It's really fundamentally just allowing us to understand what's going on with our machine learning model and our machine learning system. So I'm going to share a secret with you, which is that DevOps has figured out the secret to observability a long time ago. And that secret is logging. Actually, in the traditional DevOps definition of observability, there's three fundamental pillars of observability. There's metrics, traces, and logs. And all three of these, metrics, traces, and logs, are all just examples of artifacts that are output by a software application system, right? Metrics can be stuff like how much CPU is being consumed, what's the IO, what's the latency, are we hitting our SLAs, right? It's these numerical representations of certain metrics or quantitative factors. Traces are really important for microservice-based architecture. So, if you're using Kubeflow or Kubernetes, traces allow you to understand how data or how calls are being passed between different microservices in order to understand how a system has gotten to its endpoint. Now, finally, logs are unstructured representations or unstructured outputs of classic software applications that basically allow you to understand what's been happening within that application. So these three different pillars of observability, these three different artifacts that are produced by classic software applications are the key to observability and monitoring for those classic software applications. And this is something that the DevOps world has figured out kind of a while ago. Now, in order to take this learning from DevOps and apply it to MLOps, we need to think about how do we apply this learning around logging for software 1.0 for software 2.0, right? Because machine learning systems are in some way a superset of classic software application systems. Yes, we care about things like CPU consumption. We care about things like latency. We care about things like how data is being moved between different microservices within our stack. We care about the logs being output by our application. But software 1.0 systems are, in a sense, static, right? They're rules-based architectures. They're a lot easier to understand because there's not this black box of a machine learning model put in the middle of them. But with software 2.0, we've got another variable in the equation, right? We've got this extra thing called the machine learning model. So in addition to needing to track metrics, traces, and logs, we need to come up with a way of logging data, which is really the key insight about how to generate logging and therefore how to get observability into ML systems. We need to be able to log input data. So this is like the features or the independent variables, the output data, which are the predictions or the inferences being made by our machine learning model. And then if ground truth is available, if we're able to know the actuals, we can also track performance data, which is how is our model actually performing? And by tracking these three types of data, we're actually able to get insight into the performance of our machine learning model, and more broadly into the get insight into the performance of our machine learning system as a whole. So what's really key to understand about this is that AI observability and the ability to get observability into a machine learning model and a machine learning system sits not squarely in the MLOps space, but actually at the intersection of data ops and MLOps, right? Because in addition to needing to track these like classic DevOps components of observability, we also need to be able to track the data. We need to track the historical state of the data. So AI observability sits not purely in the MLOps bucket, but at this like interesting intersection of MLOps and data ops. So with this understanding of what was needed in order to be able to get observability into ML systems and be able to debug problems with machine learning models and systems, we built this really cool open source software library called WhyLabs. So WhyLabs is created as the open source standard for data logging, right? What it allows you to do is to take in data, be it image data, text data, structured data, whatever kind of data, and create profiles, which are statistical summaries of that data, which can act as logs. So these statistical summaries can be used in order to track the historical state, and they enable all of those use cases that I had talked about earlier. They enable monitoring, they enable debugging, they enable data documentation, all of these different things that are required for getting observability into machine learning systems. Now, one of the cool things about the WhyLabs library is that we built it with three key value propositions in mind. The first is that WhyLabs are descriptive, right? Which makes sense. It's a statistical summary of data, so it needs to be able to describe that data. Now, what's really important about this descriptiveness of WhyLabs is that they're actually more efficient in their description than the other classic summary technique, which is sampling. right? Sampling allows you to take a subset of your data and treat that subset of your data as representative of the larger data set. The problem with sampling is that, especially when you've got non-normal distributions, when you've got like a power law distribution, an exponential distribution, any kind of like long-tail distribution like a Poisson distribution, you're going to be missing things on the tail. You're going to be missing data points on the tail, and you're not going to be able to as accurately represent the distribution of data. Now, in addition to the distribution of data, WhyLabs are also descriptive in the sense that they pull out stuff like the number of missing values, the data type, all of these things that we had talked about earlier as being important to monitor in order to track data quality problems. Now, in addition to being descriptive, WhyLabs profiles are also lightweight, right? They're meant to be really small summaries of data sets. So what we've seen is that there is like three powers, like a more than 1,000x decrease in the size of a data set when it's been profiled. And that's because instead of needing to track every individual data point, what we're doing is taking a really high information entropy summary of the data set in order to generate these distributions. So these logs are a lot more lightweight, which makes them cheaper to store. It makes them cheaper to move around. It makes them easier to process. Basically, these profiles, these summaries are really useful because they're able to be summaries of data sets instead of entire data sets. Now, this last property is a little bit more confusing and is worth spending a little bit of time on. WhyLabs profiles are mergeable. And what that means is that if you take one profile and another profile, you can combine them together to create a third profile, which represents a combination of the data from the previous two, right? So mergeability is a pretty common property that we can think about in mathematics, where like one way to merge two pieces of information together is a sum, right? Adding together, if you have like a count, you can just add together a count of your apples in basket A and your apples in basket B, and you'll get the total number of apples between baskets A and B. That's like a really trivial merge, but there are more complicated merges out there, right? Another more complicated merge might be trying to merge two averages together, right? If you have a different number of variables in two different categories, you can't just add together the averages, nor can you add together the averages and divide them by two. You need to know the number of variables in both categories in order to be able to sum together this average. So mergeability is a really useful property because it enables us to deal with streaming data, with distributed systems, and it allows us to be able to zoom in and out to combine together data from, one day and another day and a third day in order to create a half week that we can combine even more to create a week and be able to zoom out across any arbitrary time scale. So mergeability is a less of an intuitive property than descriptive or lightweight, but it's a really useful property of WhyLabs. Okay, so we've talked about WhyLabs, we've talked about observability. It's all been pretty abstract. Let's dive a little bit more into like, what can you actually do when your system starts to degrade? And as I mentioned earlier, I think that there's kind of two approaches to this. There's the more like industry standard approach, which is pretty widely used right now, which I term human in the loop observability. And then there's the more bleeding edge. And, this is really where really interesting work is being done around automating a lot of this stuff, automated MLOps. But let's start with just human in the loop machine learning or AI observability. So with human in the loop observability, we've got a model in production. It's generating logs of the data that's being fed into it and the predictions that it's making. And then it's feeding these logs to some kind of AI observability platform, right? This platform probably has like some monitoring capabilities. It probably has some other capabilities beyond that. But what's important is that this AI observability platform is able to send an alert to a machine learning engineer when something has gone wrong, when there's been data drift or data quality issues, when a model's performance is degraded, whatever it might be, can send an alert to the machine learning engineer. Now, this machine learning engineer, upon getting this alert, can go back to this AI observability platform and do some kind of analysis on these logs, right? And start to understand like what happened in order to be able to really debug the system and to remediate whatever has gone wrong. And by doing this kind of analysis, they get some kind of insight, which allows them to act on the machine learning system. And this action is some kind of remediation. It might be like retraining a machine learning model. It might be rolling back a data pipeline, whatever the cause of the problem was. Because they were able to get insight into the problem, they're able to resolve the problem and remediate it. Okay, so quick summary, like with human in the loop AI observability, you can analyze the cause of system degradation. It can be a data quality issue or a data drift issue. You take some kind of remediative action, and then you go back and rinse and repeat. But we work at the intersection of two fields that are really prized for their ability to automate things, right? First, it was that software was eating the world, that software was automating a lot of the really like tedious and difficult tasks that previously had needed human labor and human intervention to participate in. So software engineering was really good at automation. And machine learning is even better at automation, right? It's taking all of these things that humans used to have to do, these like recommendations and information retrieval and computer vision, classification, all of these things. Artificial intelligence allows us to move past the need for human intervention. So the question is like, why are we allowing human intervention? Why are we requiring humans to be in the loop when we're resolving things that are based around machine learning models? And why don't we just automate this process? So the system that I propose for automating MLOps is really just taking into account what a human being does and trying to automate it. So in this more complex but only singular diagram, we've got logs that are being generated both by a data pipeline as well as by a model in production. The data pipeline is feeding data into the model, which is generating some kind of prediction and doing something with some other application, but is also generating its own logs. Now, these logs get collated within an AI observability platform, and they send some kind of informational alert to an intermediary process. So something like a PagerDuty or an Opsgenie, or maybe something built out, more custom. And within this intermediary process, these alerts are processed in order to take some kind of remediative action. So just like with a human, if there's been some kind of data drift, retraining the model is like the most classic way to solve a data drift issue. If there's some kind of data quality issue, we can roll back the data engineering pipeline to the last known good version in order to make sure that the data that's being fed into our model is the right data, is high quality data. So with all of this in mind, we can think about the fact again that AutoMLOps takes into account the intersection of data ops and MLOps in order to provide observability and in order to provide automation around the usual processes that right now machine learning engineers and MLOps engineers have to do themselves. So with automated MLOps, we can take the human out of the process. We can automatically trigger rollbacks when a new pipeline change is introduced, or automatically trigger retraining when there is some kind of model performance degradation. So hopefully this all makes sense. If it doesn't, if you have questions or concerns, super happy to answer them. Before I get into that though, Jimmy offered you guys an opportunity to get a donation to a charity. I, on the other hand, can actually offer you swag. So if you're interested in getting a piece of swag, maybe a t-shirt or one of these mugs or this really cool AI stress ball, I've got a couple of action items for you. So what you can do is you can go to the WhyLabs project at bit.ly/WhyLabs and give us a star. You can also join our community Slack, where you can talk to myself or any of the engineers that I work with, where we can debug issues for you related to MLOps problems that you're running into, and talk to other MLOps practitioners about things that you're seeing within and problems that you're solving within MLOps. And then finally, after you've done both of those things, you can submit a form with the relevant info. So just like the username that you used on GitHub, the email that you used on Slack, and then a mailing address so that I can send you some swag. And I will very, very happily personally ship you a piece of swag to thank you for your participation in our community.